Hi everybody. Okay, in this tutorial, really quick, I just want to go over how to do the quiz review assignment for this week. And quiz 4 is going to be just like this, just basically with different numbers. So watch this, figure out how to work quiz 4 review on your own, and see if you can get all the right answers and if you're comfortable with it. And then go ahead and take quiz 4 because it's going to be just like this. Okay, and this is how you'll also know what to expect, or like what answers I would be expecting from you when you take your quiz. Okay, so in this quiz 4 review assignment, you're supposed to, or you're trying to figure out if there is a correlation between the morbidities that your patients have, the amount of morbidities that they have, and the number of medications that they have to take daily. Okay, so the idea is you're trying to see if they have more illnesses or more diseases. You're trying to see if the more diseases someone has, the more medications they have to take. Okay, which I mean we would all probably assume that, obviously, duh, but we're doing a pretend study to figure this out. Okay, so what you're going to be asked to do in this assignment is to first figure out what is your X and your Y, okay, your X and your Y variables. Then you need to figure out the correlation coefficient, okay, and that's the long one, all right? So when you figure out the correlation coefficient R, we want to see if you have a negative or a positive correlation, or if you have just no correlation. Okay, so then you're going to figure out what is your least squares line equation. Okay, remember that just having that equation, you can figure out a lot of other things going on with your data. Okay, so and after that, we're going to figure out the residuals, okay, for each patient reading. All right, so that means you're going to have to calculate 3 different residuals for each one. And then that would kind of tell us exactly how far off or how spot on our least squares line equation is to the actual data. Then what you're going to do is find the CD. Okay, and then, okay, so finding the CD is going to tell us if our least squares line equation is, is good enough to use and make predictions about future patients. Okay, so that is what we're trying to figure out with this study, okay, with this pretend study. All right, so the first one, which variable is going to be your X, and then which one is going to be your Y? So the X variable is the independent variable, or the explanatory variable, the one that is sort of the one that's explaining everything, or pretty much being the causer, if you will. I don't know if that makes sense, but that's the one that causes something to happen, but it acts independently of other variables. Okay, and the Y is going to be the dependent variable, or the response variable. This is the one that you're supposed to try to see if the X variable induces some sort of response in the Y. Okay, so we're trying, basically the idea is we want to see if the X is going to cause the Y to happen. Now, I know in science we're not really supposed to be thinking that, X causes Y, because having a correlation does not always mean causation. Okay, it doesn't necessarily mean that it's going to cause it. It could just be a lurking variable that is sort of associated with, the X. So we don't know that yet. All right. We're really just saying, is there a correlation? Does it look like they're related? Okay, this doesn't actually prove that it's causing anything, but kind of the idea in your mind is what you need to be looking at, or just how you can figure out what your x is and what your y is just in your mind go, am I trying to figure out if x is causing y? Okay, so is this variable causing this variable? Is that the one I'm trying to figure? Is that what I'm trying to figure out? And if that is what you're trying to figure out, then you know what your x and your y is. Okay. The cool part about some of this work is that like when you're doing correlation work, many times if you kind of make a mistake and get your x and y wrong, you're still going to get the same correlation coefficient. Okay, and yes, your lines are going to be weird. Your line equation might kind of be backwards. It's going to be different. Okay, but you're going to get at least some of you're going to get some of this right if you accidentally make a mistake with your x and y, if you switch them. Okay, so don't stress it too much, but just try to keep in mind that when you are trying to figure out what is your x and your y, think in terms of, is this variable causing this variable to happen? Or am I trying to figure out if this variable causes this variable to happen? And that should help you put them into place. Anyway, let's just move on. Okay, so finding your correlation coefficient R. This is the hard one, or not really hard, but this is the one that you can make a lot of mistakes with just because there are a lot of steps. Okay, so the first thing to do is create this table. Okay, because this table is going to make everything so much easier for you. Okay, it has all of the parts, the pieces that are gonna be required for this equation, for this formula. So if you can get them all together, then all you have to do in the next steps is just plug your numbers in and then just do the math part. And it may be tedious, but when you organize it all nicely like this, it's clean. It's nice and easy, and the only complaint you'll have is that it's time consuming. Okay, so let's get started. This is your formula, just to remind you. But here is the table that we're doing. So we have our number of patients. Remember, we're only looking at 3, and we decided that X was going to be the number of morbidities that the patients have, and then Y was going to be our response variable, and that is going to be the number of medications that the patients have to have. Okay, so then go ahead and fill in the other parts of your table. Okay, so the next one, we're going to have an x squared section, then you're going to make a y squared section, and then you're going to make an x times y section. Okay, so all you really want to do is just start filling out the chart. So your x squared section, all you're going to do is take your x, square it, and then you get that. So you're going to take, for this one, you're going to take 1 squared, and it's 1. For this, you're going to take 2 squared, and then it's 4. For your y squared section, okay, you got to look at your y's. Let me use a different color. So your y squared section, you're going to look at your y's now. Okay, so 8 squared gives you 64. 3 squared gives you 9. 4 squared gives you 16. Okay, and now we're going to do our x times y section. So all we're going to do here is go, what's 5 times 8? Oh, it's 40. What's 1 times 3? It's 3. What's 2 times 4? It's 8. Okay, so now we have all of those in place. All we're going to do now is add everything up, because remember, we got to have the sums of everything. So let me erase this and clean it up a little bit. So we have all this filled out. All you're going to do is add all these guys up, and then you're going to get that. Add these ones up, you're going to get that. Add these up, you get 30. Add these up, you get 89. Add these ones up, you get 51. Okay, so now we have all of our pieces. okay? Because remember, this is going to be your N, okay? 3 patients, that's your total of patients right here. And then we have our sums all here. So we're going to use each one of these pieces in our equation. Okay, so here we go. Here's our equation, and we're just going to go ahead and plug everything in. So when you're dealing with an equation that's this complicated, the best thing for you to do is break up the pieces, okay? First thing you need to do to break this up is you're going to do the numerator first. What's the numerator? It's the top piece. Okay, so we're going to work on the top piece. This is the top piece right here, okay? So all we got to do, and then when we have this top piece, we can even separate this into 2 different sections. All right, so go ahead and separate them into 2 different sections. We got this piece minus this piece. Okay, so first you want to do the left side, then you're going to do the right side. So here we go. Here's the left side. And we got, just plug in the numbers. All the numbers from the chart, the table that you did in the previous section, that's all you got to do. Just plug those numbers into this and then solve. So you got the left side, it was N was 3, and then your sum of xy's, that was 51, right? Multiply them together and you get 153. Now let's do the left side of that equation. So you got your sum of x, which was 8, and you got your sum of y, which was 15. Multiply them together, we get 120. Now you have both sides of that equation. All you're going to do is plug them back in. Go ahead and subtract them. Okay, plug them back into this equation and subtract them. So we'll get 153 minus 120 is 33. Okay, now let's work on the denominator, the bottom portion. Okay, this is the bottom portion. And just like with the top, we separate these into 2 different sections. Okay. We got this section, and then we got this section. So here we are, working on our denominator. First, let's do the left side, okay, right here. So we're going to go ahead and plug in all of our pieces. Here we go. Our n was 3, our x squared was 30, and then our x was 8. Or our sum of x was 8, and then we're supposed to square that. Okay, so go ahead and keep solving. So of course we have to follow our order of operations. Okay, so the next thing that we have to solve in this situation is this part right here, the 8 squared. So we're going to do that. 8 squared is 64. All right, so that's the only thing that changed in the equation right there. And then we solve the next part below, which the next step would be to multiply the 3 by 30, because parentheses would be next. So 3 times 30 is 90, and then bring everything else down with it. So we got 90 minus 64. Then we subtract the 90 minus 64, which is going to give us 26. And remember, that's all still within that square root, right? And then we take the square root of 26, and it gives us 5.1. Yay. All right, now let's do the right side. Okay, so this is your right side. Now we plug in all those pieces from the table, of course. So your n was 3, your sum of y squares was 89, and your sum of y was 15, and then we're supposed to square that, right? So we put that all together. Now, next step in doing this type of a problem, we have to follow the order of operations. So we worry about the exponents first. So 15 squared is 225, right? Then we bring everything down, and the next thing that we're going to solve in this equation is going to be the parentheses. So 3 times 89 is 267. Then we got to bring everything else down right here. Here we are. Now we're just going to subtract these 2 numbers, all within the square root. Okay, so now we have square root of 42. And so we take the square root of 42, and we get 6.5. Okay, So then what are we supposed to do when we have our two parts? We're supposed to multiply both parts, okay? So go ahead and do that. 5.1 times 6.5, and then we get 33.15. And then what do you do with that 33.15? Well, bring it all the way back up, because remember the original equation, we had a numerator and then a denominator. Our numerator was 33, remember, from the previous slide, and our denominator is 33.15. So go ahead and divide, and we get 0.995. Now this is very, very close to 1, wouldn't you say? And it is a positive number, so this would indicate that we have a strong positive correlation. Like it's almost close to a perfect correlation. Wow, imagine that. You got perfect numbers to work with for this one. Okay, so gives us a strong positive correlation. That means it's doing something like this. And like, let's say here are the plots. I don't know. So it's doing something like this. Actually, no, that's not even giving it justice. It's, pretend it's like this, something like this, like really, really close. And the points are super close to the line. Okay. That's what it would look something like that. Okay. Okay, so next, we're gonna find our least squares line equation. Okay, so go ahead and use the exact same chart or the same table that we already made. Okay, because we're gonna use these numbers all over again. Okay, also another thing that we're going to require for this part of your problem is we need to figure out your means for y and for x and y. Okay, and you know how we say means, like in statistics, it's usually it's written like this usually, and you can call this x bar or y bar. Okay, and given that it's kind of difficult to write equations in PowerPoint, I wrote them out as x bar and y bar. So anyway, we all know how to find the means. We take the sum of your x's, we take the sum of your values and we divide it by the total number of those values. So basically, x bar, or the mean of the x's, okay, is going to be 8 divided by 3, which gives us 2.67. Same thing with the y's. So we find the mean of the y's, which is going to be 15 divided by 3, right? 15 divided by 3. And that is going to give us 5. And we are going to use that in our equation. So remember that the least squares line equation has to look like this. Okay, this is the goal, right? And these are the equations for A and B. Okay, so basically we had to find these and then we just plug those into the equation. And of course we have to figure out B first, okay, because in A requires us to have B. Okay, so let me clean this up because it looks bad. All right, so now let's work on B. This is another one of those complicated looking formulas. So what we're going to do is we're going to break it into parts. Okay, we're going to take care of the numerator first and then we'll do the denominator. All right, so now we're just going to work on the numerator, or the top part. Okay, and the numerator can definitely be broken up into two different parts, right? We got one part here, and then we're going to subtract it by the second part, which is right here. So let's work on the first part and then we'll work on the other part. So this is super easy. Here's the first part. And so n is 3, and then the sum of your x times y is 51. So just multiply the two and we get 153. Next, the second part, or the part on the right, is sum of x's, which gives us 8, and then the sum of y's, which gives us 15. So you just multiply the two and we get 120. And then all we gotta do, remember, we have to subtract them, because like, look at the formula, right? So you just subtract them. 153 minus 120 gives us 33. So we already have the top part. Okay, the top part is 33. Now we're gonna look at the denominator. Let's go. Okay, now we're at the denominator. This is the bottom portion. And looks like it can be broken up into two different parts, right? So we got your right part, your left part, and then we'll do your right part, and then we'll subtract the two when we find our different parts. Okay, so here's your left part. And what super easy, it's just take your n, which is 3, and then the sum of your x squares, which is 30, and multiply the 2, which gives us 90. Then take your second part, okay, the second part right here, which is the sum of your x's, and then square that. So that will give us 8 squared, which is 64. Okay, and then all we got to do for the denominator is subtract the two parts, right? Remember, we were subtracting the two parts. So go ahead and subtract the two parts. We got 90 minus 64, and that gives us 26. So now that we have both parts, we can go ahead and put them together. Remember, 33 was our numerator, 33, and then our denominator here is 26. So go ahead and divide, which is going to give us 1.27. This is your slope, or your b, if you will. Now let's find a. And this one is super easy. Here is our equation. So we have to take our y bar, or your mean of the y's, and subtract, or then we minus b, which is what we just found, the 1.27, and your x bar, which is the mean of the x's, right? And we saw this on the other page, so you can go ahead and look back if you want to check and make sure we have our numbers. So anyway, our y bar, okay, or the mean was 5, right? And then our b, or our slope, was 1.27, because we just figured that out. And then our x bar, or our mean of the x's, was 2.67. So we have to use order of operations, which means you got to work your parentheses first. So go ahead and multiply these two first. Okay, and then we get 3.39. Okay, and then so all we're going to do is subtract 5 by 3.39, and then we get 1.61. Okay, so this is your A. And then you can, now that you have all your pieces, your two pieces, the only pieces you need for your least squares equation. So now we can go ahead and write out our least squares line equation, which is going to be y equals 1.27x plus 1.61. Okay, that is it. That is the moment we've been waiting for. Just kidding, there's more. Okay, so now for each patient we want to find the residual. Okay, and how do we figure out what the residuals are? Well, basically, remember what the residuals are? Pretend we have a graph, right? And we have some points, and then we have our line, and the residual is how far off the points are from the line. So we're just calculating what this little space is. And the idea is that if it's too big, then this isn't a very good line. If it's small, then it's a good line. Okay? So, how do we find the residual? The equation to find the residual, the space in between the actual point and your line, we use this equation right here. It's just y minus y hat. Okay? So your y is what we were given. So this is the actual point on the line. I mean, this is the actual point on the graph, on the scatter graph, right? And then your y hat right here, this is the y you get from the line. Okay, so this is the value. Sorry, I should not have deleted this, but so the y is the y value that's on the actual line. Okay, so we want to figure out the difference between this y and this y, and that will tell us how good our line is. So how do we do this? Well, we get to use the line equation that we just made. Okay, so for each patient, okay, what you're going to do is plug in the x that goes to that patient, or that goes to that thing. You're going to plug that in for x. Okay, and then you solve it, you do your math, which is basically you multiply 5 by 1.27, and then you add 1.61. Okay, that's all you got to do. That will give you h hat, or y hat, sorry. That will give you this number. Okay, so you want to do that for all of them. So for patient 2, you got to plug in the 1 in here. You're going to multiply 1 by 1.27 and then add 1.61. Okay, and then that will give you 2.88. Then for patient 3, you're going to take your x, which is 2. You're going to multiply it by 1.27 and then add 1.61. Okay, and whatever that gives you, well, that should give you 4.15. Okay, so now we have all of our h hat values, and we have our h values. Well, we've already had our h values. Okay, so at this point, all we gotta do is minus our y's from our y hats, just to find the difference. So we're gonna take our 8 and minus 7.96, and that will give us 0.04. Then for patient 2, we're going to take our 3 minus 2.88, and that will give us 0.12. Then for patient 3, we're going to take 4, and then we're going to minus 4.15, and that will give us negative 1.5, or 0.15, sorry. Okay, so then you can look at these numbers and go, those are actually really, really small numbers. And then you can go, well, you know what? I think that makes the line equation that we have pretty darn good. Okay, so finally, your CD. All right, so find the CD and then tell whether or not you think that the CD value, the percentage, is going to be high enough for us to be able to use the least squares line equation to predict how many medications patients may require in the future, okay, depending on their number of morbidities. Okay, so basically, CD, all you have to do to calculate this is plug in your R. Remember our R was 0.995. So all we're going to do is plug that in to this equation, right? And all that equation is doing is squaring it. So we're going to square 0.995, and that is going to give us 0.99. Okay, and then of course we have to turn it into a percent. So all you do to turn things into a percent is what? Move the decimal over twice, or multiply it by 100, if you want to get technical. But anyway, that will give us 99%. Okay, so when it's 99%, that's actually a really, really good CD. That means it's very high, and that is a good equation to use to predict the future, or just to predict how many medications that a patient might require in the future, depending on how many morbidities they have. Okay, and that's it. There you go. I hope that this clears things up for you guys, but if anyone has any more questions, please let me know so we can make sure that we're all good to go.